And good afternoon from our Boston Regional Training Center here in Nashua, New Hampshire. I'm Matt Schwegler of ITC. Welcome to today's tutorial on the basics of optical gas imaging. Before we start though, just a couple things I want to mention. We are recording today's webinar, so if you want to hear this for playback at a later date, on our website at infraredtraining.com/webinars, there's about 24 topics that are there right now. There's an older version of this presentation. We're going to have this one replacing it here in the next week or two. For those of you that have registered and have joined us, you will be notified when that presentation is ready. And of course, our training schedule is available off the ITC website, infraredtraining.com/schedule, with dozens of training dates across here and across North America, including our optical gas imaging classes that Ron will talk a little bit about during the presentation. You can register for any of those at infraredtraining.com/schedule. And if you're joining us here from Europe, the Middle East, or Africa, irtraining.eu is where you can go to get a list of classes that are available in your region. All right, I think we'll start it up.
Cool.
Let me give you control, Ron, and then you can start here with today's presentation on the basics of OGI.
Just wanted to give you a short introduction as to what optical gas imaging is. This is kind of like a real short subset of our courses. Our courses run 2.5 days, and so this should run maybe 20-25 minutes or so. Okay?
Perfect.
Yeah, perfect. So what I want to do is to explain a little bit about the basics of optical gas imaging. It's new to some people, it's old to others, but it's been a fascination of mine since we first came up with a camera in 2005. And I do spend a lot of time training on folks. So a little bit about the fundamentals and just how to detect some gas. We'll review some applications and we'll look towards the future a little bit. Regardless of what camera you have, whether it's an optical gas imaging camera or a regular thermography camera, you should always make sure that the first purpose of your survey is your own personal safety. And we've seen this many, many, many times where folks have walked into a gas stream, they walked underneath something that was very, very hot, like an electrical connection. So prior to even entering an area that might be classified, where you might need a hot work permit, you should do a wide area scan. And what we're recommending in our classes now is to start from some arbitrary distance and look in the camera with the OGI camera. If you don't see anything hot, cut that, or if you don't see a gas leak, cut that distance in half and repeat that process. And then repeat it one more time. And what you've done, if you don't notice anything in the long distance, medium distance, or short distance, you've eliminated all the massive leaks, eliminated all the intermediate sized leaks, and what you're really left with are the small leaks. And then it's more or less safe to enter that area if you have the permission to do so. So the second purpose of the camera, of course, is optical gas imaging. So after you've inspected the area that's safe, you have to wear all the required PPE, the personal protective equipment, and make sure that you know what is specified for that area. Very, very, very important. And it's very easy to become complacent. This is a little video from a class that we were teaching, and the fellows on the left-hand side were down looking at a leak. And that particular area there, if you can kind of see in the background, it'll be in through here when we go into the high sensitivity mode, right in the center there. There was a much, much, much larger leak, and that had filled the building up with gas. And we had a lot of fresh air where we were standing, but you just walk around the corner on the other side of those compressors there, and we were already at 20% of the lower exposure limit, the 20% of the LEL for that gas. And so it's incumbent on everybody to make sure that you're not walking into something. We did identify where that leak was. We had to do it from a distance, and they got folks right on it right away. So always know your surroundings. And the OGI cameras, the optical gas imaging cameras, show us what would normally be invisible to us. And this fellow just walking right up the top of the tank there, and he's just going in there to do some tank gauging, and he's standing right in the plume. Apparently the hatch was open, or he left it open. I'm not really sure of the story. This was from several years ago with a previous camera that we had. But you can see that that person there is getting an awful lot of gas. We have a lot of questions. I get a lot of questions almost every week. I'm looking at X gas. What camera do I need? And the camera that we make a variety of cameras, everything from the GF304, the 304, which sees refrigerants, to the 306, which is sulfur hexafluoride and ammonia, to our hydrocarbon cameras, which are our 320 series, 300 and 320 series. And then we have a 343 for CO2 and a 346 for carbon monoxide. So there are quite a few gases that are available. And you really need to know, quite a few cameras that are available. You really need to know what gas you're detecting, because that depends on which camera you're going to use. For example, I recently had a class where a fellow had a GF343, a carbon dioxide camera, and wanted to know why he could not see methane in his plant. He thought a GF camera was a GF camera. Well, he needed the CO2 camera, but he needed to purchase or rent another one. It's just incompatible to that particular gas. A little bit about the current state of the regulations, and these are changing as we speak, but back in 2016, the EPA, United States EPA, published an amendment to the regulations that really impacted this industry. It's known as Quad OA, and it recognizes optical gas imaging as the best system for emissions reduction, BSER. And they compared that with bubble testing, with the Method 21, which is a traditional Eldar sniffing test, and found out that the OGI was more effective, could catch a lot of the bigger leaks. And so that regulation, Quad OA, applies only to newly installed compressors and wells and associated equipment, not refineries, not chemical plants, not existing components, just the new stuff. A lot of my clients have adopted Quad OA as a best system for emissions reduction, and they look at everything, even though they're not required to, but they do it on the guise of Quad OA. And here's their statement. It says the EPA's analysis for the proposed rule found OGI to be more cost-effective at detecting fugitive emissions than the traditional protocol for that purpose, which is Method 21. And the EPA therefore has identified OGI as the BSER for monitoring fugitive emissions at well sites. And so they found out that it was just a lot easier. And from a practical standpoint, you can sit back 10, 15, 20 feet and see a lot of leaks, where you would have to get up in close proximity to a connection to sniff it. So from a personal standpoint, you have the opportunity to stay in cleaner, fresher air. So this is a little chart right from the EPA. For those who are not familiar with it, their original recommendation here was for biannual monitoring. I know some others, some folks have gone to quarterly. Some have actually gone more often than that. They go almost a monthly survey. And a lot of requirements. This is a huge regulation. You have to read through it. But I pulled out a couple of key paragraphs. And this is a 60.5430A. Any component that has a potential to emit fugitive emissions of methane or VOC at a well site, a compressor station, including but not limited to, and they list pretty much everything here, from valves, connections, flanges, pressure relief devices, lines, instruments, meters, compressors, covers. I mean, they throw the whole ball of wax. So basically, you have to look at everything and come up with a plan on how to do that. One item that keeps coming up in a lot of my classes are folks that are finding cracks in welds. That is not listed under Quad OA, but that certainly would be a structural issue as well. And I think in the past year, I've had maybe 5 or 6 people that actually found cracks in welds. I've only found one in my entire career. No tagging of the components is required. So when you find it with an OGI, you document it with a picture, GPS, time, date, etc. But it does not require tagging of the component. Method 21 does. And you have to have a very detailed documented plan. And we're going through a rewrite right now of the OGI class. So I'm going to be putting more and more of this OGI Quad OA information in there. And so folks can follow up on that. Some general requirements, you have to say how often you do it, what your method used, the manufacturer of the equipment, that would be us, and how we certified our components. You have to keep your records for about 5 years. And a couple of things that come up specifically is the training and experience of the operator. You have to document that, as well as the procedure for calibration and general maintenance. So they're asking for the whole shoot match here. So 2 sections of the regulations that generate a lot of comment, particularly us, is how do you qualify your folks? They want the assurance that the personnel using these components are adequately trained. They don't tell you to come take an ITC class, but a lot of folks do. I've recommended, I was in a facility just the past 2 weeks and recommended that they create an entire written practice and procedure for this, and they started on that before I left. And so now they'll have good documentation of every person that's out there with a camera.
Had a question that just came
Sure.
in about any requirements for, I guess, liquid natural gas inspections or ship-based.
That would come under Coast Guard regulations.
Okay.
And Coast Guard doesn't have any regulations for us, but anything on the water is basically under the Coast Guard.
Okay.
Yeah, so we would love to be able to have Coast Guard say, hey, you have to inspect all of your LNG stuff or your barges, because I've been at the Houston Ship Channel, watch barges go by and see gas coming out of them, gas vents. Now, we saw that with a class one time. I don't think it's very common, but it was that one time. So yeah, there really isn't that I know of at this point. Okay. Maybe sometime in the future. We wrote the first OGI class and delivered it in 2005, and so that's what almost that's 14 years.
Yeah.
This is an older technology now. It's a mature technology, I should say, and so it's been a lot of fun, learning with folks. And so the regulations are going to change as well. One thing for the calibration and maintenance, we recommend that you send the cameras in annually, even if they don't have to be calibrated, because right in our manual, in every GF manual, paragraph 3.2, it says if your sole purpose is for gas detection, you don't have to send the camera in for calibration. The calibration is a temperature calibration. But that being said, I can't tell you how many cameras I repair in class. I do very, very simple repairs. The lenses are all dirty. Things are broken, and we get them set up for the RMAs, the Return Manufacturer's Authorization. I would highly recommend, for the amount of money that's invested in these cameras, that folks do send it in on an annual basis. We can check on it. A couple of other things that show up here, and everybody should have some way to demonstrate their initial and daily verification checks. If you're using this for Quad OA, you have to prove that the camera can see gas every day, and there's a whole procedure specifically for that. And also to ensure that you have adequate thermal background. And I was so thrilled when I saw that in the regulation, because that is what we preach to and have been since 2005. There has to be a little bit of energy, either warmer or cooler, behind the gas to get really successful gas imaging. And the max wind speed procedures are always, we get questioned on that. On our website, flir.com/OGI, optical gas imaging, you will find the independent test report that was done for our GF cameras in response to Quad OA. And I believe there's a chart there that gives you the maximum wind speed and tests, et cetera. But to keep one thing in mind, for all that independent testing, that was done with a 1% diluted gas. So it was 99% nitrogen, 1/2% of propane, 1/2% of natural gas. And so the test was done under, with a very, very, very dilute gas. And we were able to see it, probably up to, I think, 20 miles an hour leaks. So the cameras are extraordinarily sensitive. And that would be mostly in the high sensitivity mode of the camera. So, and you don't have 1% diluted gas inside the pipe. You have 100% concentrated gas in the pipe.
Had a question,
Sure.
Thoughts on using the camera in the rain or when it's snowing?
Oh, that's a great question, because these cameras are IP54 rated, which means that they're good for limited amounts of dust and moisture, basically.
Right.
And I've had them out in the light rain, not pouring rain like we have today in New Hampshire, but light sprinkles, it's not an issue. With snow, it is definitely not an issue, other than the fact that if you go into the high sensitivity mode, it just drives you crazy because it sees the change of the position of the snowflakes.
Huh.
And it's very difficult to pull out the gas leak from all the snowflakes coming by. It's crazy. So the HSM is not very good when it comes to snow or even raining. You can actually see the streaks. But I've used it in both situations. The most difficult one, obviously, is the initial daily verification check. And they give a little bit of guidance on how to do these. They tell you specifically you need a 98% pure gas that you can see, but then they don't really tell you much more than that. The issue isn't with our cameras. Our filter is built internal to the camera. We actually protested this, the initial daily verification check. And EPA said maybe your cameras are okay, but there are other manufacturers and there may be new technology coming out in the future. So they still wanted everybody to do this. I made a little lab. Let's see if the video will play over there. I made a little lab with just a little flow meter. You can see it in a propane tank. And that's about a 5 gram per hour flow rate. Most testing is done at 60 grams per hour. And so initially, it's very, very difficult to see where that gas leak is. It's right up the top right there. And you go into the manual tuning, and you'll start to be able to see the gas a little bit. There we go. You can see the gas coming out of the hole. But when you go into the high sensitivity mode, we'll really get to see the gas. And I change we have 8 levels of high sensitivity, which is a continuous image subtraction. And the 0 would be for the very, very large leaks, the 7 for the very, very small leaks. As you can see, as that image degrades, the whole thing fades away. And that's just the time between failure. And that flow meter was barely indicating. You can get an idea as to, that's that little black bead there, as to how much gas was coming up. So these cameras are pretty sensitive. If anybody wants to build one of those little flow labs, you can email me, or we'll put the parts up here. It's a very, very simple, costs less than $100 to make. A bent piece of aluminum and a flow meter, about $150 in parts, I guess. And but I can get you all the part numbers for everything. And we use this in all of our classes. Okay, just a little bit about the gas detection. How do we see a gas? Well, a gas has to absorb energy within the bandwidth of the detector. And so if you're looking for sulfur hexafluoride, which is out around 9 or 10 microns, you're not going to see that with a mid-wave camera. So we need it has to absorb energy within the bandwidth of the detector, and we have to have a corresponding filter. And so those are the two most critical things, and having a little bit of background energy to absorb. And there's always been a discussion as to how much temperature difference we need between us and the background. And I think the official FLIR line is 5 degrees C, 9 degrees Fahrenheit. We routinely do this in class with less than 1 degree C, about 2 degrees Fahrenheit. And so the cameras are much more sensitive. So inside our camera, we have a little cold filter. The filter is at the same temperature as the detector. The detector is cooled down to liquid nitrogen temperatures. And so everything is nice and cold. The filter doesn't add any energy. And it just makes for seeing the gas a lot easier. So filtering, if you can imagine the energy on the left is everything from 3 to 5 microns. We put a very narrow notch filter in there, and we just limit it. You know, for example, for methane, it's about 3.2 to 3.4 microns, somewhere around there. And so we just let that amount of energy in. And the reason why is different gases absorb energy at different ways. And so what we've got here is the dark gray line there is how that gas absorbs. The yellow is what our filter looks like, sort of. And the crosshatched area is the amount of energy available to be absorbed by the gas. And so it's a very simple thing. So we can see something like propane. There's a big area. If we were to calculate that area, that's a large area to see. propane is very easy. A lot of people are interested in methane, CH4. It's just a very, very, very noisy molecule. And there's not an awful lot of energy there. So we can see much smaller leaks of propane than we can of methane. So every gas is a little bit different. And here is another gas, ethylene, very common, that has a small absorption in the midwave, so a GF320, but a huge absorption in the long wave for the GF306. So our recommendation, if you're a primary producer of ethylene, you would opt for the GF306 so you can see the smallest leaks. And where all these data come from is the webbook, the NIST, webbook.nist.gov/chemistry. If anybody's interested, I have an entire library on an Excel spreadsheet, and I'd be happy to email that to anybody. And it'll show you which gases are available. Few applications. One thing you can see here with virtually any infrared camera, if you're at the right time of the day, you can get an indication of tank level. And that doesn't require an OGI camera. You can do that with a regular thermography camera. Here is a gas leak off of a valve on the top of a tank. And we're going to, this is a student video. We always ask them to invert the color palette, go through all the color palettes, and then go, and submit that to us. So there's a whole variety of leaks there. And this was in an area where the local, it's in a state that has a lot of regulators, let's put it that way. And they hadn't visited here yet, so it was really fortunate that we found that before they came up to look. Internally is a compressor building. This is a separator, and that's the flow control valve, which vent normally. And so they're designed to vent gas into the building or into the environment. That's what they do. But they're only supposed to vent gas when the valve is moving or when it's changing level, doing its deal. And this was venting continuously, so that was a problem. Controllers are not part of Quad OA because they vent continuously. And there's a fair amount of gas, as you can see. I'm going to show that in high sensitivity mode. And so they're not normally inspected, but it's always a good idea to take a look at them. On the really upstream side, here's the some producing wells. And this was a case where the gas was coming from around the wellhead, both wellheads. And as we'll see here in a moment, it was coming out of the ground. And so I don't know whether the entire casing had an issue or what the situation was, but this was not a good thing to find, because you just can't isolate that. It's coming right out of the ground, and you'll see it's coming right in through there. Obviously not bad situation. So, but that's why you go out with an IR camera and you take a look. Okay. And it's not only hydrocarbons that we look at. This happens to be sulfur hexafluoride, and that is a large 345,000 volt breaker, 345 kV breaker, and powering a massive amount of power going through there. Probably a couple of cities go through that area there. And you cannot see the leak. None of these leaks are visible until you turn on the IR camera. And here, that's just in the high sensitivity mode, the HSM. Normally, I use a tripod. You can see the breakers up through there. So it was the center one up through there. And normally you would use a tripod, but the static voltage was so high in that switchyard that day that we couldn't. It was wrecking the camera. The camera was rebooting.
I had a question come in from Luis about pneumatic controllers.
Yeah.
And leaks.
Yes.
Not for thermal imaging, or
oh yes.
Is it?
Oh yeah.
Okay.
Oh yeah.
What's some background on that?
Well, you mean an air?
Yeah.
Okay.
That's where I think he's going.
All right.
to.
Yeah. If that's an air controller, no, we can't really see that. The air would have to be really, really, really hot, and you'd need something. You could do it with a science camera. I've done it before.
Okay.
But no, if you're looking for pneumatic leaks like an air leak, airborne ultrasound is far easier.
Okay, so he's saying oil and gas and natural gas operated.
Oh, yes. For those, yes.
Oh, for those, yes.
Yes,
okay.
for those, yeah. Like I've seen big Valtex. They're huge diaphragm type operators, and those have gas on both sides of the diaphragm for a control valve. And they vent out generally through a charcoal canister, so people in the neighborhood don't smell it. because it's at a lower pressure. So there, we're very, very successful at seeing that.
Okay.
Yeah.
Okay, great.
Yeah.
And this also.
And this also. Here's that's carbon dioxide coming out of a cow, a couple of cows there. And so anybody who has a desire to go inspect cows to see if they're breathing, we have a camera for it. But it's a CO2 camera. It's used for a lot of other things like electrical switchgear. We'll finish up here. We're just going to look a little bit forward. We now have the Flir Gfx 320 camera. It is class 1 div 2. And you can see from that drop test that they dropped it for quite a distance. And I've actually had that happen in class, with a student not understanding how to operate my tripod, dropped the camera on the floor and almost passed out. Oh. And I picked the camera right up, put it right back on, and it still works to this day. And, but your heart stops for about 10 seconds. We don't want you to do that, but the cameras are really, really, really rugged. Wow. So, and that's for hazardous environments where you can get in, some place will allow you to operate in a class 1 div 2 without a hot work permit. Okay, but it's not class 1 div 1, it's not intrinsically safe. So to finish up here, we regularly conduct optical gas imaging classes. We welcome new users. I think we probably have 30 or 40 of them a year, quite a few. And this field is always evolving, and we're having to change our course material all the time just to keep up with the own technology that we have here. So with that, thanks for everybody's time, and if you have some more questions, I'll be happy to answer them.
Yeah, some questions did come in. Looks like we had a couple questions come in here at the end. Ron, one was regarding Quad OA and the rule states pneumatic controllers not operating under normal conditions are considered leaks, correct? He's
correct.
Not sure. Okay, so correct. Okay.
That's our interpretation, yes.
Okay.
Yes.
Okay.
Yeah.
Ed.
But you're always best to check with EPA or your local regulators.
Just in case.
Just to see what they say, yeah.
Understood.
Yeah.
Any issues, this is from Ed, traveling through airports with any of the GX cameras or anything?
We haven't had I personally have not had an issue. We do hear occasionally folks, when they try to put it through the X-ray, TSA yells bag check, and they make them take the batteries out. And so
really the batteries are the issue.
Really, you're not supposed to have the lithium ion batteries in the hold of an aircraft. What I do, and I show every class, I start out, we open up the camera case, and I pull my batteries out. I have bright yellow tape taped on the contacts of my batteries all the time, except when I'm using them. Why not black? Well, I did put black tape on there one time, stuck the battery in the camera, and the camera wouldn't turn on. I'm looking like an idiot up on top of the class, in front of the class. So I use bright yellow or bright green or bright orange, something I can see. And the one time my case did go through and TSA flagged it, the guy just opens it up and he pulls the battery out because he knew what they were. And he says, "Thank you for taping your contacts." And I was allowed to bring that into the, right on the airplane. It wasn't an issue.
Okay.
But if you check your camera as luggage, if you're going to check it as baggage, make sure that you get down to baggage claim before anybody else. Don't stop for the bathroom or anything like that. Run, because you get a lot of money there, and there have been the occasional cameras that have come up missing.
Yeah,
not from us.
If it's me, I'm not checking it. It's never
I FedEx all my cases, and so I don't. Only in an emergency would I have to take it.
Okay.
Yeah.
Let's see. Another question coming in here from Grayson. Let's see. So can you use an optical gas camera on DTM valves for Eldar in oil and gas refinery?
Absolutely. I've got so many videos of difficult to monitor locations. And that's the preferred method. They'd rather you not climb up into an area where you could risk falling or risk opening, closing a valve or tripping something. So the OGI cameras, we have all the way down to a 6-degree lens that you can put on these cameras for long distances. And some of the biggest leaks we found have been in the difficult to monitor locations. Yeah.
Okay. Have you tried detecting small leaks? This is small ammonia leaks from Mark with these cameras. How effective was it for leaks that are less than 1 pound per minute?
I've never tried to find an ammonia leak.
Okay.
Yeah, so I have no experience there. And 1 pound per minute, I would say that you probably would have to be in the high sensitivity mode on a tripod to see that. But yes, the one thing that is available to you is to not record a video to the students, to rotate the the video file format. I think it's in menu 3 to sequence. And these cameras will record a 15 frames per second sequence. Now, you can't really do much of that other than play it back and thermally tune in Flir tools. But in our researcher software, we can add the high sensitivity mode and a whole bunch of other filters to help find the very, very, very small leaks.
Okay.
For example, I found carbon monoxide leaks with my T650 camera, and those are 2 incompatible wavelengths, just by finding out where the hot air was going and imaging the very, very hot air.
Okay.
Yeah.
Okay.
So, but that was done with the researcher software.
Okay.
Yeah, which is expensive.
Any way to measure the quantity of gas leaks? Quantity measurement.
Yeah, quantification.
Yeah.
I didn't have time to really spend much time on the Providence Photonics QL320. They make an add-on to the cameras that does some quantification. They've got new software out. I'll get to see it in 2 weeks, but a lot of folks have been using that.
Good.
Yeah.
I think we covered it all. All right.
Excellent.
Thanks. Thank you, folks. Thank you for the questions. That was great.
Excellent questions, yeah.
I think we'll wrap up today's webinar. We have recorded this, so we'll have it available for playback at a later date. If you want to watch that, you can head to infraredtraining.com/webinars, where we have this and about 24 other topics that are available for viewing at any time. Well, enjoy the class.
Sure will.
Enjoy the week.
Alrighty.
We'll be back online again here soon with more live webinars, of course, on Facebook, Twitter, LinkedIn, Instagram, YouTube. And of course, you have to email Ron or myself. We have our addresses right here. All right. Thanks for your time.
My pleasure.
Thanks for joining us, folks.
Thank
We'll
you.
see you online again soon at a future live web event from the Infrared Training Center. Have a great weekend.